morning, everybody, and welcome to this month's edition of Carpe Datum Prescriptions. My name is Shirish Netke, and our topic today is a debate on is data science dead? And arguing in favor of the motion is Miko Matsumura from Hazelcast, and against the motion is Bruno Aziza, CMO of Alpine Data Labs. Miko, Bruno, welcome to our program.
Thanks for having us.
Thank you very much.
So, a quick housekeeping note: we're going to go through over the format of the debate. Each speaker will have 4 minutes to speak, beginning with Miko, followed by a 3-minute rebuttal. After that, we will have 8 minutes for questions and answers from the audience and from the moderator, followed by 2 minutes closing statements from each speaker. So, with that brief introduction, let me turn the floor over to Miko Matsumura. Miko, go right ahead.
Great. Thank you very much, Shirish. So I just want to set the ground for this debate, which is that, I think that the factual discussion around this debate is really not salient, which is that, data science can actually not be dead because it was never a living being. So then I think that what the debate has to turn on, really what is the intention behind this sentiment? Why is this being debated and why is this being put on the table? So I will articulate it this way, which is, I wrote a piece on Slashdot called, in fact, Data Science is Dead. And what was my intention? Who was I attempting to serve with this? So to me, I was actually looking at young people. I was thinking about college students, people planning their careers, people searching for jobs. There's a lot of people searching for jobs out there in this economy. And so I was thinking about those people and how they plan their careers. And, there's a lot of hype right now. And so my concern is that vendor hype can actually drive career decisions and lead people towards difficult situations. So, I think that to me, what I wanted to say just off the top is, why is my perspective of value in this? So I think first and foremost, I have formal training as a scientist. So I did get my master's degree in a PhD program at Yale University in neurosciences. So I've done bench science. My brother is a tenured faculty member at Emory University, and my father was also a research scientist. So I come from a background of scientists, so I take the concept of data science very seriously. I work at Hazelcast, which is a company that has a number of big data customers. And so I'm in hundreds of big data conversations. And, I've been, as others, as Bruce has been as well in the Valley for many years. And I've watched the boom and bust cycles in this economy. So I've seen people get pushed into funny job titles. And, to me, the concept of data scientist is maybe close to the idea of something like a webmaster. I mean, it's possible that you might not harm yourself by having that title for a short time. But I think that, right now, what's happening with the Silicon Valley bubble around big data, you just saw Cloudera raising, $900 million in a single round. So, I mean, there's definitely a little bit of concern that this is getting a little overinflated. I think that it's necessary for someone to at least say that the emperor, ain't got no clothes. So, that's my perspective, which is that, from that frame, I think it's important to try to understand what is it that's left of this role in an enterprise once the machine language, the machine learning and automation systems take a bite, once the database administrators take a bite, once the business analysts take a bite, once the computer scientists take a bite, including IT developers, and once the sort of product management and product marketing team take a bite. So, all of these different roles already exist in the traditional enterprise, and they're going to be competing for this function within the enterprise. So there are tons of people. So to me, everyone must become a data scientist, and that the specific role of a data science is, I think, out of scope.
Okay. Thank you, Miko. Now we go over to Bruno Aziza from Alpine Labs.
All right. Well, so I'll bring a slightly different perspective. Actually, I'll argue that data science, the term, has been in existence for over 40 years. Actually, if you look it up on Wikipedia, I think 30 years, and was popularized by Peter Noor. So I think data science is a very strong, very real um, discipline. And I agree, I think, with Miko that there has been a lot of confusion in terms of what constitutes a data scientist. But I think the reason why data science will never die is because it's at the core of everything that we do on a daily basis. And I think we hear a lot about it today because of big data. And I think in the era of big data, you'll realize that strong data science ends up in math, and math wins. Math always wins. When you look at companies like Facebook and Google and Amazon, you can't say that these guys haven't won in their space because they didn't have data science. They absolutely won because of the power of being able to analyze at scale a large amount of data and put it in context in front of end users that would be able to um, use that math to buy things and refer others. So I think that's my point of view. Is data science is very real. It's a very solid discipline that is built on the back of decades of work in the statistical area, and it can never die. It's at the core of everything that we do. Now, what I will say in my argument today is that the industry is struggling with scaling that. And we've had two issues. One is we've said everybody should be a data scientist, and that's really not realistic because it's very difficult to make everyone a data scientist. The other perspective would be, well, we don't need data scientists at all, and we can replace them by other types. And I think that the industry needs to look at the problem of data science and saying, yes, we are going to miss, according to McKinsey, I think 200,000 people that could potentially be analytical leaders. But the question is, how do you go about scaling it? And I think it comes from the connection of two things. One is realizing what data science is and how you scale it across the organization through software applications that help you do that, but also recognize the respect that we must have in hardcore data science, which is, again, the engine and at the core of everything that we do.
So that's fantastic. Now, Miko, would you like to take your time for a rebuttal?
Yes, happy to do so. So, I do agree that to some extent that data science can never die. I'm not sure it was ever alive. The fact that it's been around a long time, it could be like that TV show, The Walking Dead. So to me, the thing that I think is great and valid is the idea that math always wins. That's a nice idea. However, I think what's problematic here, though, is if you do cite, for example, one of the originators of the big data movement, Yahoo, with all of their important role in spawning the Hadoop project, uh, I'm not convinced that Yahoo is winning or is a winner. So I think that it certainly doesn't necessarily work that way, and I'll tell you why. The reason why is fairly simple, which is that math is, or maths plural, are basically abstract systems, right? And so it's in the application of the abstract system to reality where things get much more complex. And when you start mapping abstract systems to business realities, you get into the realm of what has been called lies, damned lies, and statistics. And there is, in fact, a wonderful book called How to Lie with Statistics. And it's a very easy thing to do because when you have a data set that's big enough, you can actually do all kinds of amazing tricks. So, for example, my neuroscience professor once said to me, if you give me enough degrees of freedom, I can model you an elephant. And if you give me one more degree of freedom, I can make his nose light up when you pull his tail. Which is a bit of an absurd statement, but it really indicates that given a domain of sufficient size, you can have an extremely fun time inventing business cases that business people will want to argue, right? But the thing is that math of course, always wins, but the question is which math applied to which data. And so the selection of data becomes very important. And this comes back to the data issues. So to me, one of the biggest big data issues is the selection of data and the capture of data. So, to me, for example, Google flu trends was actually had a recent failure because their data capture continued to change over time. And so, one of the things that we see is we see things like master data management, data cleansing, data staleness or data recency, and huge expensive proof of concept projects that create overblown expectations for big data. So those are all of the kind of basic concerns that I have about this realm that people are stepping into so boldly.
Thank you, Miko. Bruno, over to you for your rebuttal.
Yeah. So I think, first of all, I think if I can rebut on just what we're talking about today, I think, making the veil between big data, Hadoop, and data science, that's where I think confusion starts, right? Because Hadoop is not big data, and data science is not big data only either, right? So I think, that's first thing to clarify is what is data science? Data science is the application of statistical model and math on any type of data set. So it could be data, small data, big data, medium data, it could be Hadoop, it could be a CSV file. But I think what we're talking about here is that the importance of statistical science and how it can help businesses drive better results. And I think in your example of Yahoo, I'm not going to comment on Yahoo, but I'll give you the examples of companies like Amazon that are turning the industry upside down, that today are so confident about their math that they'll actually deliver to your door a package before you order it. That's the value of math, right? And so those are the types of companies I'm referring to. Now, the problem that they have today is how does everybody get to that stage? First problem is a human problem. We don't have enough data scientists. We'll never have enough data scientists. So how do we use tools, applications that allow us to scale across the organization? The second thing is really realizing that data science is not only not going to die, but actually is going to become hotter and hotter as we go. If you think about the opportunity that we have, in the past, you could say by using business intelligence tools that, look, you can use intuition because business intelligence tools don't give you access to everything. Now that's not true at all. We can capture almost anything. And what is going to be differentiating and allow companies to win and compete is their ability to filter all that noise into just a few things that are relevant at business speed so people can take action. That's the value of data science. In today, organizations complain that they're not able to make decisions fast enough. Well, what happens when you have a bigger view and when you don't have the math to guide you? So I think that's the opportunity where I kind of would disagree by saying everybody's going to be a data scientist or big data and data science are the same. I'd say the first one is it's not just about the data scientist, it's about how the data scientist engages with the rest of the organization, the IT organization, the line of business and the executives to feed their model into the rest of the business. And then secondly, it is about looking at more data sets across multiple types of businesses to filter the noise and get to the signal that's really relevant. Data science is not just dying, it's actually becoming hotter every minute we talk about it. I think Al Varian from Google said a few years ago that the statisticians and the data scientists were the hottest job of the next century. I think he was absolutely right.
Okay, thank you, Bruno. And Miko, thank you for stating your positions and your rebuttals. We will now go to questions submitted by the audience. And we'll start off with a question submitted through online during registration. And the question is as follows, and we'll give you each a few minutes to answer. The question is, how will the gap between data analytics and business decisions be bridged in the future? More specifically, how far can data-driven decision automation go, given that the senior level executives may not be data savvy? Uh, Bruno, I'll let you go first.
Yeah, so I'll start by answering the last question first, which is how do you get this data-driven into the worlds of executives and so forth. I think the bigger question is today we're struggling as an industry on establishing the relationship between people and data. There's three types of relationships: people and data, people and people, which is what we're doing now. We're talking, Data and data, which is automation, data
Uh-huh.
acting on data, and then data and people, which is basically what is your relationship with the data that you have in front of you. Business intelligence, the relationship used to be data gives you an errand. You're looking at operational reports and they tell you, hey, you need to go out and do certain things.
Mm-hmm.
Now, with advanced analytics technologies, we're able to flip that relationship, which is, I think, answering your first question is, how do you get to a stage where analytics is running your company? Well, you put your data to work, and you put your data through models, through prediction analysis, so they can, in some cases, automate,
Mm-hmm.
and in some cases, pop up in processes so they can inform you of what your next best move is.
All
So
right.
example scenarios would be product recommendation. Again, I point to Amazon. How did they automate the math at scale?
Mm-hmm.
Recommend a product on what you know about me.
All
And
right.
banks and companies do this on a daily basis.
Great. Miko, would you like to answer that question?
Yeah, so I would first like to just directly address the issue of Amazon. So, Amazon, the case of Amazon in terms of product recommendations and package delivery was effectively described as math and data science. Well, to be honest, if you actually look at both of those examples of predictive package delivery, things like Amazon Locker and things like recommendation engines, there is a job title that's associated with the person who does that, and it's called a software developer. So Amazon hires lots of software developers, and in fact, they are ruling the roost. Coming back to the question at hand, it does talk about this concept of data-driven decision automation. So one thing that we're seeing rampantly across the industry is ultra high speed decision making and decision support. So obviously there are policy style decisions that require human intervention, but we're going to increasingly see radical automation through things like evolutionary algorithms and through things that are basically developed by people with job titles like engineer and software developer and programmer.
But you're not saying that we need to hire more software engineers and developers to get that in the hands of people, are we?
I certainly think that there's going to be more need for software engineers, developers, and programmers than anyone with the title data scientist.
Okay. Thank you, Honorable. Let's go over to the next question from the audience. And the question is, why should data science be a distinct and separate specialty when everyone who handles data needs these skills? Bruno, once again, if you could answer first and let me go.
Yeah. So I just want to bounce on Miko's last comment. I think that's the confusion today is that when you want to hire a data scientist, I was actually looking this up before, we don't have a good job description of what that person is. And sometimes they do hide behind the software developer role, and sometimes they don't. I think the organizations that win are able to not just hire some of the great data scientists, but also scale that across the organization. I think the number one mistake that companies need to avoid making is ignoring the talent that they have inside the organization and going out and hire a bunch of data scientists away from the Facebook and the Google and so forth. And so the model today is how do you identify the talent inside the organization? You
Mhm.
might bring a few people from the outside, but again, it's about scaling that data scientist outside of the data science world. And the titles that need to be included here are business analysts, line of business managers, and executives. So I guess to answer your question here is that everything has to start at the core with math. That's the best way to drive competitive advantage. And if as an organization you don't believe in that, I suggest you look at the companies that are winning today, and they'll tell you there's hardcore data science behind our models and why we do things. Thinking that you can completely replace the data scientist by other roles, I think just leads to shallow results and ignores this idea that our life runs on data science.
Very good. Thank you, Bruno. Miko, would you like to answer the question?
Yeah, so I think the answer to the question is no, it should not be a separate and distinct specialty. I'm certainly not proposing that math is dead. I think mathematics is alive and
Okay,
well.
that'll be another debate.
Yeah, exactly. I'll be on the con side of that. So to me, just the short version of the answer should be that programmers and developers should probably all do a much better job studying in math. And if you are in college at the moment, please study math. That's a wonderful thing to do. I'm a very strong proponent.
Okay, good. Let's go to the next question from the audience. And the question is very brief. It says, if data science is dead, has BI been reincarnated into analytics? It's kind of a two-sided question. But
Yeah.
hey, Bruno, I'd let you
All right,
go
so,
first with
so I
your
think
answer.
the first argument, I think, you know what my position is. Data science is not dead, but I will point to something I see here as a theme is that it seems that in our industry, every 2 years we come up with a new term.
Uh-huh.
You know, 1 year it's scorecard, the next year it's dashboard, 1 year it's business intelligence, the next year it's analytics, and we just kind of love this, buzzword and acronym soup. And I think, I think there are multiple levels of how you could probably help here this question. The first one is, I think what we talked about is what is data science? It's the use of statistical methods and models and processes to the service of the business. They can represent themselves as analytics. So they could be a prediction model, they could be a churn model, they could be a product recommendation model that could be identified as an analytic. I think the main difference to make here is not so much as BI coming back into analytics, is what is the difference between BI, big data, and maybe predictive analytics. And I think I talked about it a little bit earlier. BI, when you think about business intelligence in general, it's about operational reporting, it's about visualization, it's about thinking about the past. Data science and analytics is thinking about how do we now use this past to prescribe what's going to happen next. That's how I think about the value of data science. I don't think I need a data scientist to figure out my average sales, because that's just total sales divided by number of orders. Any business analyst knows that. But if I want to know, based on your age, your ethnic origin, the stuff you've bought before, what should I offer you next, and what's the likelihood that you will take that product from me, that's data science.
Okay. Miko, what's your answer?
Yeah, so if discovering those correlations is data science, then you can crack open a copy of Tableau and everyone can become a data scientist. So last week Thursday I was in Bangalore, India, providing a keynote for the Big Data Day at the Great Indian Developer Summit. So in front of several thousand developers there, I basically said, is big data analytics actually a fundamentally new information processing organ for enterprise IT? Or is it just an incremental improvement over everything in the past? And my argument was effectively that this is not the evolution of the equivalent of the human neocortex. This is not like an amazing leap forward. This is an incremental leap forward. I think the amazing leap forward will be the combination of real-time in-memory analytics with something like evolutionary algorithms and machine learning. That combination will actually result in an extraordinary leap forward in people's ability to process data, in a much more business time meaningful way.
Okay, thank you, Miko. I think we have time for just one more question. And this question is, I guess there are two questions. One is for Miko, the other is for Bruno, as you can see here. The question from Miko is, if the title data scientist is unhealthy, what would be an alternate label we can use to describe the role?
Yes. So, I think that the alternate titles could be database administrator, it could be business analyst, it could be programmer, developer, software engineer, it could be product manager, it could be business line manager, it could be product marketing manager, it could be, in fact, machine learning algorithm. So there may actually be computational robots that can perform this kind of a job. So, I think that one of the issues I have is that everybody's going to take a bite out of this role function, and there's not going to be much left.
Okay. Now, the next question is for Bruno. Can you elaborate on what you mean by data science values?
Data science values. Okay. I think if you look up, the definition of data science, or the types of things that people look for in a data scientist, you'll find a great article on the three criteria you look for, and I think they're a mix between hacking skills, knowledge of statistics, and what's called substantive expertise, which is understanding of the business in general. I think what I was referring to earlier, and I'm just going to go back to a comment Miko made earlier, we actually do partner with Tableau, and I'll tell you, it's a little dangerous to say just crack up Tableau and build some statistical models, because the reason why my company partners with Tableau is because we have this root in data science, and we want to put it in the hands of business analysts. So I think I want to warn people here and say you can't turn just your average business analyst, and you should not say that data scientist is dead and we can replace them with all business analysts. That is not the right approach. The right approach is data science is a discipline, and the difficulty we have today is scaling that across the organization. So some of the values that you need to have is one, collaboration. How do you make sure that your data scientist team is building and is not in isolation? How do you make sure that the work that they do is scaling across the organization, it's protected as an asset, and gets in front of the executive? Now, will this require participation from the business analyst? Absolutely, because the last thing you want is business analysts or data scientists doing rework or building something that actually already exists. And then finally, in terms of making that visible to the executives, it's really important that the organization realizes that data science is a core component of treating your data as an asset across the organization. And when I think about the organizations that we talk to today, we talk to banks and they say, "Oh, we have billions of dollars in management." And I think, have you done the same thing about your data? How much data and how much data science do you have today and you hold today under management as an asset? And that's the discussion, I think, that's going to tip this industry over, where you'll see the role of data science really permeate across the entire enterprise.
Great. So thank you very much, Miko and Bruno, for answering questions from the audience. We'll now give each of you 2 minutes to close your for closing arguments, and then we'll take a poll of the audience. Miko, you go first.
Yes, so just to kind of like light on kind of the core topic question there, which is it relates to how do you depict the future, right? Because to me, this is really about what we're pointing towards. And I have on my blog a post that I wrote called "The Future Will Be Warm and Creepy." And the concept that I'm really driving at is this notion that, in fact, big and personal data will be shared, and that data will be subjected to radical algorithm crawling, right? So the creepy crawlies are essentially and effectively machine learning algorithms. And that, to me, what's going to happen next is an explosion of predictive and an explosion of in-memory real-time the streaming moving data analytics and complex event processing. So when you start to move, and this is based on my personal experience talking to Hazelcast customers who are doing this kind of real-time event-driven architecture. And so when you start to see this kind of capability in combination with machine learning, you start to see the future as emergent in this form. And when you do look at this, all of a sudden you start to see that the ability of machines to reason and the ability for metaprogramming models to exist to enable this kind of machine reasoning is actually more the high order bit, and that obviously human reasoning will play a pretty critical role in terms of governing the business fate of these types of projects. But I guess my last parting shot would be please be careful with the job title of data scientist. I do think that big data is happening. I think that math is important. But I also think that people need to watch their career investments carefully. So that's my closing note.
Fantastic. Thank you, Miko. Bruno, for your closing argument.
Okay, so I'll leave you with 2 stats. The first one is I was talking about companies like Amazon, Facebook, and Google earlier. If you look at across the industry, only 4% of companies say that they're able to connect their work in data science and big data to better decision making. So we have a crisis here that basically indicates that everything we've been doing in the past really hasn't worked. And what have been the options? One, to do data science at scale, it's complex. And you can look at all the companies that have offered that before, and I think the stat that I brought up is basically showing the failure in that model. Option number 2 is we should make the tools available to everyone. It's a visualization thing, and when you have better pictures, you can have better results. And I think when you look at that, that's really the business intelligence argument. 28% adoption rate of BI tools. So neither of these approaches have worked. When you think about data science and the opportunity you have inside your company, you got to think about it as a drastically game-changing approach. Now, there's not one silver bullet, but I'll give you one that is actually coming here from a report I'm holding in my hand from IDC on data science in the age of big data. And they show that the high performers have a highest level of collaboration across the organization. This is IT, data science, executives, and line of business. But then the low achievers. Now, the difference is not important. It's more than important. It's 30 points. So the winners have a 65% plus collaboration percentage. The losers have a 35 less percent collaboration percentage. So what that tells us is that while we've been focused on defining job descriptions, talking about technology investments, what we forgot is actually to bring people around the table, IT, data scientists, and other departments inside the organization, and allow them to work together so there's no rework. We manage the asset or data as an asset across the organization, and we're able to respond faster than anybody else. So when you think about, is data science dead? I think my closing statement is no, not only is it not dead, but it's going to be more and more important as you're going forward. Don't look back for the models you've been used to, because they really have failed us. So you need to look at new ways of looking at it, and collaboration is the first thing that I would look at.
Okay. Thank you both, Bruno and Miko, for this most exciting debate. We have the polls open for the audience right now to vote in favor of yes or no. And we're going to close the polls in just about another 10 seconds, and we'll read out the results. Again, thank you very much for all of you for attending. The data science for this debate is sponsored by the Sandhill Group, and all of those, I think 10 participants who have submitted questions and who are attending the debate will get a copy of Sandhill Group's recent report on big data. Now, I do have the results in. The results are 20% in favor, 80% not in favor. So the answer is data science is not dead. Thank you very much. And thank you for attending the Carpe Datum Prescriptions event for April 2014. Thank you all.